All right, hello everybody. Welcome to another live stream. This time though, we'll do some integrations and we will do 10 integrals, and these integrals are from the 100 integrals. And you can go download the file in the description. These are the questions that we'll go over today. And let's see, hold on, let me make sure that everything is going well first. All right, we are going to get started shortly, so just give me like 20 more seconds or so, because I want to make sure that everything's okay. All right, so I need to adjust the phone a little bit. All right, so I'm using my phone, so you guys can leave your message. I can see the chat, and we will be doing the question soon. Okay, perfect. All right, so we are going to get started. Here, these are the questions that we'll go over today, but we are just going to go over what the first move is, what the integration technique that we have to do. We are not going to solve everything because all these questions are from the 100 integrals. The link will be in the description, and that's why you will see that the numbers are 1, 2, 4, 7, 8, 10, and 20, and so on, because these are the numbers from my 100 integral video. All right, so let's go ahead and get started. And of course, I need your help. Let's take a look at the first one. We have the integral of tangent to the fifth power x times secant to the third power x dx. How do we start? I'm just going to write down the first few steps, and then once we see how it goes, then we'll move to the next one. Oh, you completed 100 integrals 4 days ago. Nice. Yay. So this is the first part, the one from 2019. So I'm waiting for you guys. Please let me know what you think, what the first step is. This is the integral. So Rob, you said let u equal to secant x. Before that, we should make some change a little bit though. Is it secant x or tangent x? Because I see another Cyrus. Yes. Hi. Hello. You said it's tangent x. So it depends on how you want to work this out. So we should kind of change this a little bit. This is the product of tangent to some power and secant to some power, and we have odd powers. We don't like odd powers. True that. So what should we do first? Can we do something with the 10 identities and simplify first? Yes, but before that, maybe we want to fix the powers. Pull our secant and turn the rest into secant. If you pull our secant, this is still an odd power for tangent. So remember the identities for tangent, you should see some even powers. If you let u equal to secant x times tangent x, the derivative is going to be quite crazy though. If you let u equal to this, if you take the derivative of that, wow, you will have to use the product rule. You keep the first one times the derivative of the second, and yeah. So, don't think so. That's not going to work. All right, so what's the first move? What's the first move? Let me see, I think I saw a message. Okay, pull out a secant and also a tangent. Yes, we are going to pull out both of them, right? But just one power, right, for each one. So we look at this as the integral, keep this as tangent to the fourth power x, and then write this as secant to the second power x. And then we will have tangent x, secant x. But let me write it as secant x and then tangent x, like so, and then dx. So we still have secant to the third and then tangent to the fifth. Now, we hope that this part is just an expression in terms of secant x. Therefore, we should change this, right? Have a look. This right here, it's the same as something squared, and of course that is tangent squared and then squared. Tangent squared is equal to what? There's a trig identity for that. Yes. So this right here, it's the same as secant square x minus 1 and then square. So as you can see, this right here, we can turn this part into an expression in terms of secant. And we still have this secant square x, and then we still have all this part. Secant x, tangent x, and then dx. Now, if you just look at this portion, then we can just do u sub. But you have to study out like this first. So right here, we let u equal to secant x, and then you see that right away, du equals secant x, tangent x, dx, which is just this. And then you can take this part to the u world, and then I'm going to leave that for you guys to continue. I'm just going to put down dot 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 from here. Again, today we'll just talk about what the technique that we have to use, right? So take a look. Let me know if you guys have any questions. I'll pause for like 15 seconds. You guys can go download the file in the description. These are the questions that we'll go over today. So I do have a partial fraction question at the end. And if you guys look at the numbers right here, the last one is number 65 because that's question number 65 from the 100 integrals. 30 seconds. Right, just 10 more seconds. Okay, I don't know if that was 10 seconds or not, but we're just going to continue. So that was the first one. Now, for number 2, this is also number 2 from the 100 integrals video. This right here is the integral cosine of 2x over, and on the bottom we have sine x plus cosine x. And I picked these questions because I think this right here, if you are in Calc 2, then you should know this for your final. If your final is in like 2-3 weeks. If you have taken your final already, then yeah, you can review this, just for extra practice. Oh, thank you so much, Nemo. Thank you so much. How often do I stream? I plan to stream in May a lot more, so I can help my students prepare for their final exam as well. Right now, I have 4 streams planned. Integrals, derivative, limits, and also series, mainly for Calc 2. And you guys can go to the community tab. You guys can go download the questions. Yeah, it's also in the description of this video. But anyway though, how do we do this right here? How do we do that right here? So let me just take a look at the phone, make sure that the stream is going well. Oh, nice. Yay. All right, Jay, that is correct. This is the double angle for cosine, so we can actually change that. So I will just give you guys some hint. So cosine of 2x equals cosine square x minus sine square x. And this is very nice because this is a difference of 2 squares. So this right here is cosine x minus sine x, and then we multiply that by cosine x plus sine x. So if we put this to the top, and we can see that sine x plus cosine x cancel each other out. So you pretty much just have to integrate this right here. And then I will leave that to you guys to finish everything. By the way though, I would like to remind you guys, when you are integrating sine x, this is just a nice reminder, what's the answer for the integral of sine x? What's the integral of just sine x? Negative cosine, right? X. And then if you integrate cosine x dx. This right here gives you sine x. So of course, don't mix up the sign right here, positive or negative. So that's number 2. Okay, nice and straightforward if you know the double angle identity for cosine. All right, I think it's a lot of fun whenever we are just talking about like how to integrate something and then we just focus on the strategy. For example, the next one's number 4 from the 100 integrals video. I have this one, the integral of x plus e to the x and then squared dx. So what will be the first move for this one right here? Can we just do a u sub, let u equal to x plus e to the x? Expanded. Okay, because if you just let u equal to the inside, then you will see that du equals 1 plus e to the x dx. And there's nothing on the outside that can cancel with this, right? So u sub is not going to do it. But if you multiply this out, if you expanded the binomial, this right here is the same as the integral. You square the first term, which is x squared, and you add 2 times this and that. So it's 2x e to the x. And lastly, you square this. E to the x squared is e to the 2x dx. And you just integrate term by term. And now, here is a small part though. For this one right here, when we integrate 2x e to the x, this is a standard integral to use integration by parts. More importantly, you can use the DI method, of course. And hope your teacher accept the DI format for it. It's not a shortcut. It's really just the same as integration by parts. If your teacher does not believe the DI method, please send your teacher my video. So hopefully that can convince him or her for the DI method. But anyway though, this right here, you do the D and I, plus, minus, plus, differentiate 2x, integrate e to the x. Do it, you get 0, done. Integrate, and then again, you multiply the diagonals, and I will leave the rest to you guys. Right, so just put dot, dot, dot. Integrate this, reverse power rule. Integrate this, don't forget to divide it by 2. Just like this. Okay, any quick questions? I forgot to ask you guys if you guys had any questions earlier for the previous question, so any questions on that, on this one? Oh wow, we have about 120 students, 120 viewers. Wow, this is like 3-4 classes. Very nice. No questions. Okay, cool. This is live. Yes, this is live. All right. I'm not solving everything though, because all these questions are from the 100 integral videos from 2019, right? Okay, the next one is question number 7 from the 100 integrals video. Integral of 1 over square root of e to the x dx. If you have any questions regarding the DI method, you can just search DI method by Blackpen Redpen on YouTube. And I have done like several videos on how it works, why it works, and how to convince people that it's actually legit. So you can just do that. Oh, thank you so much, Dave. I'm glad that you like your plus E hoodie as well. Thank you. It's the same as integrating x to the negative e to the negative x over 2. True that, because this right here is just a square root, which is the 1/2 power. So it's just doing some algebra. This is the same as 1 over e x over 2. Then we can bring this up and we can look at this as the integral e. Let's write this as negative 1/2 times x and then dx. So it's just integrating this. All right, let's see if you guys can tell me what the answer is. I'm going to skip some steps. I will just write down the answer for you guys. So what's the answer for this? Yeah, once you do this, this is e to a number, right? It's a constant times x to the first power. You can figure out the answer right here very nicely. All right, thank you guys for the answer. This right here equals, this part repeats, e to the negative 1 over 2x, but you divide it by this coefficient. Dividing by negative 1 over 2 is the same as multiplying by negative 2 over 1, which is just that. And of course, you can put this at the... You can put this on the bottom. And some people will say you have to put on plus c, but I usually just put on plus c at the very end. Here is negative 2 over this. It's the same as that. It's the same as this, which is the same as the square root of e to the x plus c. Yeah, so I finished this one for you guys. All right, so just like that. All right, so we have 4 questions and 6 more to go. Right, 6 more to go. All right, number 18. Question number 18 from the 100 integrals. That's why the numbering is like, why we are number 18 already? But anyway, though, we have the integral, and we have 3 over x squared plus 4x plus 29 dx. By the way, you guys can download this file in the description. It will take you to my Patreon page, but it's just a place for me to like put up my files there. All right, so let's take a look at this one. Complete a square. How can we complete a square? Because if we look at the bottom, x squared plus 4x plus 29, we cannot factor it with real numbers, right? So complete the square right here. So let me just show you guys how it works real quick. X squared plus 4x and leave a space and then plus the 29. For this number, you take half of it, right? Half of 4, and then square that. Half of 4 is 2, square that, we will get 4. So right here, we should have a plus 4, and then after this, we should have a minus 4. Then we can see that this right here will give us, the first 3 terms becomes x plus 2 squared, and then this right here gives us plus 25. So the denominator is really just x plus 2 squared plus 25 because of the completing a squared. So now, we look at this integral, 3 over that, x plus 2 squared plus 25 dx. And right here you can do a u sub, but it doesn't really matter that much. U equal x plus 2. du is the same as dx. So you don't have to divide it by any extra constants or anything. You divide it by 1, but it doesn't really matter. But I will remind you guys, whenever you are integrating 1 over, let's say, let's use u. I'll write down the formula for you guys. U squared plus some number a squared in the u world. This right here, you get the inverse tangent. You get 1 over a first, and then multiply by inverse tangent of whatever the u is, divided by a. Right? So inverse tangent, and that's what you will need for this one as well. And again, go ahead, work it out and all that. So put on ... And if you want to see the worked out solution, just refer back to my 100 integral video. Okay? All right, next one. Next one is going to be quick if you see how it is. Number 20. Integral, here we have tangent of x to the 4th minus x plus 1 dx. from -1 to 1. So for this one, let's figure out what the answer is. It's an odd function. By the way though, this function is continuous from -1 to 1. So there's no debate, right? Because if you look at the integral from -1 to 1 of 1 over x dx, this right here is debatable. But I will tell you the answer for this right here is divergent. This is a divergent integral. If you want to say this is 0, then that's called the Cauchy principle for you. But we're not talking about that. Because this right here is improper integral since x cannot be equal to 0. However, for this one though, our function here is continuous from -1 to 1, and I will tell you this is an odd function. Odd function means, I'll write this down for review purpose, f of -x equals -f of x. Then we see that right here. In tangent of x, tangent is odd. This right here, oh sorry, I forgot the square. Sorry, I forgot the square. Sorry. It's meant to be x of course minus x squared plus 1. Oh, otherwise I cannot solve this either. But anyway though, this is even, the bottom is an even function. An odd function divided by an even function gives you an odd function. That's why the whole thing is still an odd function. Yeah, it was my bad. It should have been an x squared right here. So for this one, whenever we're integrating an odd function from -a to +a, right? These two numbers are the same but opposite sign. And if this is continuous, then we can say this right here equals 0, and then we are done by integral property. All right, so that's that. Okay. Now, number 22. So integral of 1 over x squared times the square root of x squared plus 1 dx. So a lot of these questions are meant to be reviewing for your Calc 2 finals. And I just got them from my 100 integral video. All right, tricks up, tangent, yes. Whenever we see like x squared plus 1 instead of the square root, yeah, tricks up works wonders. So let x equal to tangent theta, and then remember dx equals, what's the derivative of tangent theta? What's the derivative of tangent theta? Thank you, Carol. Secant square theta d theta. And then you are going to take this integral to the theta world and then go ahead and just kind of work it out. Work it out completely. If you're in Calc 2, if you have your final exam coming, this is the kind of question that you definitely have to review. By the way, if you have finished your Calc 2 class already this semester, just drop me, just put on me in the chat so I know you are done with Calc 2 this semester. I don't know, some schools they are already done, but like for our school, we still have about like 3 more weeks. So that's why I'm doing this. If you have your final exam coming, either in late May or early June, then hopefully this right here, you find it helpful. Now, 26. Let's look at the integral of cosine of square root of x dx. A lot of you guys finished your final already, huh? Now this semester, I mean. But if you have finished calculus 2 like in the previous semester, that's cool too. And then thank you for coming here, review some integration techniques. For this one, again, it's a pretty standard calculus 2 integrals. You have to use integration by parts. But before that, yes, you have to take a u sub, right? Whenever you have square root inside of the sine cosine functions or e to the x, I will tell you this one, and also similar questions, integral of sine square root of x dx, and also integral of e to the square root of x power. All this right here, you start with that u equal to square root of x. And then square both sides, we get x equals u squared. Then take the derivative right here, we get dx equals, put the 2 to the front, and then subtract 1, so we have 2u, and then du. So all this right here, you do it like this. And then we will take this integral to the u world, and we will get the integral cosine square root of x is the u times dx is 2u du. So you get the integral of 2u cosine u du. And this right here, we are going to do integration by parts with the DI method, of course. So make sure you differentiate 2u and integrate cosine u. Differentiate it one time, differentiate it again, we get 0. And for this right here, integrating cosine u, we get positive sine u. Do it again, we get, u. Do it again, we get negative cosine u. And then you can construct the answer from here. And then don't forget to get back to the x world after you are done with this expression, right? Oh, by the way, yes. Yeah, that just remind me. The AP Calculus is next week, right? The AP Calculus test is next week. But any questions for this one right here first before I erase? Okay, cool. Yeah. I did a 2023 AP Calculus free response questions on my main channel. You guys can go check it out if you are preparing for your AP Calc exam. All right, number 34, that's the next question. So I just have 2 more questions for you guys, right? Just 2 more for today. And then if you guys go to the description, that will take you to my Patreon, and there are 4 files. Those are the questions that I plan to go over. For the integrals and the series, we'll just talk about the strategies because I have worked out all of this in my previous video already. And then for the derivative and the limit, I will actually work it out with you guys. All right, number 34, integral of natural log of x over square root of x. Again, the standard calculus 2 integral that you have to know. But maybe when you learn integration by parts, that was like 2-3 months ago, in the beginning of the spring semester. So it's like, what should we do, right? Yeah, another integration by part question. But why though? I will tell you. Anytime you have the integral in terms of x to some power p times ln x dx, integration by parts, right? Very, very standard, very, very common integral that you have to know for your Calculus 2 class. And for this one though, we are going to differentiate and integrate here. We'll differentiate ln x, right? You always differentiate the ln x part. And then you integrate x to some power p. This is square root of x on the bottom. So you integrate 1 over square root of x, which is the same as x to the negative 1/2, right? So that is x to the negative 1/2. That's why this integral is in this form. Then you just do it. So differentiating this, you get 1 over x. Integrating this, you add 1 to the power. Negative 1/2 plus 1 is positive 1/2, and then divided by 1/2, it's the same as multiplied by 2 over 1. So integrating this, we get 2 x to the 1/2 power. Or you can also write this as a square root. But for this one though, you multiply the diagonal, that will be the first part of your answer. Then you are going to multiply these 2 things in this row and still put that inside of the integral. And then you still have to integrate the product of this row. and I'm going to leave that to you. All right? Okay, just one more for today. Number 65. When p is equal to -1, if this is just x, you can actually just do u sub. But if you would like, you can also do integration by parts. Technically, integration by parts will always work, but sometimes it helps, sometimes it doesn't. Sometimes it's more difficult, sometimes it's easy. So anyway, though, 65, last one. This is the last one of the live stream today. Here, integral, and we have 1 over x to the third power minus 4x squared dx. Yeah, very, very classic partial fraction right away, because we have a rational function. The bottom is a polynomial, we can factor it, right? If you factor it, what do we get? Be careful though, this is x to the third power minus 4x squared. If I change this to just x, then it's a different factoring. This is slightly more difficult. You factor out the x squared, yes, thank you, Carol. So I will just put it down right here, x squared, and then we get x minus 4. And then we are going to do partial fractions. So this one is the same as saying 1 over x squared times x minus 4. And now what's the setup though? Aha, yes. When we have x squared, you have to build up the power. That's how I like to think about it. You start with x to the first power, and then you build it up to x to the second power, because this is the repeating factor. Then you see that this right here is a linear term, so the top is just going to be a constant. And then when you build up the power, the top stay the same kind. Constant, constant. And then the last one right here is x minus 4, which is linear, so that means the top should be a constant as well. All right, and then go ahead and figure out A, B, and C. And I will tell you though, for B and C, you can use the cover-up method for it, which is going to be, just do what we have done before. So try it. I review the cover-up method for figuring out the constants. And yeah, after that, you just integrate the first, integrate the second, integrate the third. Shall I explain why do we have to have this term? All right, I'll do that for you guys too. So this is how you should set up if you are familiar with the integration by the, if you're familiar with partial fraction, you could just write that down and just do it. Now, if you want to see why we have to have that extra first power on the bottom, this is why. This right here is your first part, right? X squared. You can write it as x squared for the first fraction, and then you add it with the next fraction, that will have x minus 4 on the bottom. Now, if you break it apart like this, it's okay, but you have to remember, this right here is a quadratic. That means the top will be a linear. So I will put down ax plus b. This right here is a linear. The top will be a constant, so you just put down c. The top will be 1 degree less than the bottom. And the reason is because if you have the same degree, let's say ax squared plus bx plus c, well, same degree, you should have done polynomial long division first. That's why when you set up partial fractions, the top should be 1 degree less than the bottom. So this is okay. Now, this right here, we see that we can split the fraction, We can write it as ax over x squared plus b over x squared. And then the last one is c over x minus 4. And what's the first one? Look, x and x squared, we can reduce one of the x's. So we do end up with a over x plus b over x squared plus c over x minus 4. So that's why that we must have this term. And it really depends on what you have on the numerator here. Sometimes you'll see that, oh, a is 0 or b is 0, so it's a, do we really need to set it out like this? I will tell you, this is the complete setup whenever you have this kind of situation, right? So, go ahead and figure out what A, B, C's are. Did anybody figure out B and C already? Let's say, let me just put this down. All right, I'll wait for you guys. If you guys figure out A, B, and C, then we'll call it for the day. Okay, what's A, B, and C? B is negative 1 over 4. I haven't checked it yet though, so I'm just going to write down whatever you guys have on the chat. C is negative 4. How about A? A is positive 4. So in this case, we do need all these three terms. And after you have all this, you integrate the first, you integrate the second, and you integrate the third. And perhaps let me just get some confirmations with these numbers. I hope I'm not blocking any of the numbers right here, right? Okay, so that's pretty much the idea, and yeah, that's it for all the 10 questions that I wanted to go over with you guys today. Okay, let's do a quick Q&A for like 2 minutes or so. Any questions in general, anything that you guys would like to ask before we go today? Yeah, this is just like an online class, but I don't know who's watching. I cannot see the students, but yeah, it's kind of cool. Oh, thank you so much, James. I am happy to hear that. Yeah. Why did I make this YouTube channel? Because I still want to produce like just tutorials for calculus, and for my main channel, I want to have the freedom to teach whatever I want on my main channel. And sometimes I want to do like more difficult or like more fun stuff or like crazier stuff. For this channel, I just wanted to be more focused with like class related or like more tutorial based. Yeah. Any tips for linear algebra? I have not taught a linear algebra class before, so sorry. No, but I can recommend you to watch Dr. Pan's video and also 3 Blue 1 Brown. Yeah, they have good videos on linear algebra. Will I teach differential geometry? No, sorry, I don't know about differential geometry. That's out of my ability. Yeah, I mainly teach Calc 1, Calc 2, and then algebra at my school. Yeah. Why? Last question. Why did I pick blue pen and red pen? I am going to assume you mean black and red, right? I think just black and red, they have like really good contrast. And if you like basketball, then you should know Michael Jordan, Chicago Bulls. Their color is black and red. Very cool combination. Yeah. All right. Anyway, though, thank you guys so much for coming. And until next time, I will see you guys. Just kind of make sure to subscribe so that next time when I go live, you won't miss it. And go to the description. You can download the files so you can see the questions that we'll be going over next time. Okay? Bye.